Hello, everyone, and welcome. In this explainer, we're going to break down the fascinating world of electric current. We'll look at circuits and discover some of the amazing and sometimes surprising things they can do. So let's get right into it. So let's kick things off with a little game. I'm sure you've seen this one before, right? The How Steady Is Your Hand game. It's actually a perfect example of a simple electric circuit. You've got your power, a switch, the whole deal. But imagine trying to draw this thing on paper. It looks pretty complicated, doesn't it? And that leads us to a really important question. I mean, there has to be a simpler way to draw all of these parts, right? क्या इसको बनाने का कोई आसान तरीका है? Well, the answer is a big yes. Scientists and engineers have a kind of secret code, a special language made of symbols. This makes it super easy to draw circuits, and anyone in the world can understand them. Let's learn this language together. Okay, so take a look at this. This is what makes everything so much easier. Instead of trying to draw a realistic battery or a light bulb, we just use these simple symbols. See, a long and short line for an electric cell, a little circle with a cross for a bulb. It's like a shortcut that makes drawing circuits super fast and clear for everyone. All right, now that we know the language of circuits, let's talk about what makes them go. The power source. Every single circuit needs one, and most of the time, that's a battery. It's pretty much the heart of the whole operation. So everything really starts with this little guy, the electric cell. I bet you've seen tons of these, right? In your TV remote, in toys, they're everywhere. And you'll always see it has two ends, a positive side and a negative side. This is the basic building block of our power. And here you can see exactly what I mean. On the left, that's just one single cell. But look at the right. We've got 4 of them all lined up together. See how the positive end of one is touching the negative end of the next? That's really important. And that's it. That's what a battery is. It's just 2 or more cells joined together. When you link them up like that, you get more power, which is exactly what you need for things that use a lot of energy. यानी कई cells को मिलाकर एक battery बनती है. Okay, so we've got our symbols, we've got our battery. Now for the fun part. What actually happens when we connect everything and let that electric current start to flow? Well, something pretty interesting starts to happen. Let me ask you something. Have you ever noticed how a light bulb gets warm? Sometimes even hot after it's been on for a bit? I'm sure you have. So what's causing that? Why does it heat up? Well, the reason is actually pretty simple. Whenever an electric current flows through a wire, that wire gets hot. Take a look at this experiment here. That's a nichrome wire connected in a circuit. And as soon as the switch is flipped, you'd be able to feel that wire getting warmer. And this simple fact has a very important name. We call it the heating effect of electric current. It's one of the most basic and powerful things about electricity. The flow of current creates heat. Simple as that. And you know what? You use this effect all the time, probably without even thinking about it. Things like an electric room heater, an electric iron, even the geyser for hot water or your hairdryer, they all work because of this very same heating effect. But wait, there's more. Heating isn't the only trick electricity has up its sleeve. It has another hidden power, something that seems, well, almost like magic. Let's check it out. Okay, look closely at this picture. We've got a wire, a battery, and a compass sitting right next to it. Now, watch what happens when we let the current flow through that wire. The compass needle actually moves. How is that possible? A compass needle is a magnet, so what's making it move? This experiment shows us something absolutely amazing. It proves that a wire with electricity flowing through it acts like a magnet. It creates its own magnetic field around it. And we call this, you guessed it, the magnetic effect of electric current. So, electricity can create heat, and it can create magnetism. That's a lot of power. And as we all know, with great power comes great responsibility. So it's super important that we talk about how to stay safe. Let's think about a potential problem for a second. What would happen if, for some reason, way too much current started to flow through the wires in your house? Well, remember that heating effect we just talked about. More current means a lot more heat. And if the current gets too high, the wire can get so incredibly hot that it melts and breaks. And what's worse, it can even cause a fire, जिससे आग लग सकती है. And this picture shows you exactly how dangerous that can be. That little piece of steel wool just melts and breaks almost instantly when too much current passes through it. That is precisely what we want to avoid happening inside the walls of our homes. So, how do we protect ourselves? We use some very clever safety devices. On the left, you can see an older type, called a fuse. And on the right is something you've probably seen in your own home. That's a modern MCB, or a miniature circuit breaker. Now, both of these do the same basic job. If the current gets too high, they break the circuit to stop the flow. The big difference is how they do it. A fuse has a special wire inside that just melts, so you have to replace it. But an MCB is more like a switch. It just flips off automatically, and once you fix the problem, you can just flip it back on. Pretty neat, huh? So to wrap things up, we've covered a lot today. We learned the secret language of circuits, we talked about batteries, and we discovered the amazing heating and magnetic effects of current. Most importantly, we saw how things like fuses and MCBs keep us safe. All this makes you wonder, right? Electricity powers our entire world, so the big question for the future is, how can we make it even safer and even more efficient? It's something for all of us to think about.